scholars, welcome to another Smash Jam series, and today we're going to be looking at gas laws. Now, this is a very important part in Jamb Chemistry. So let's go up ahead and look at these questions. Now, the first one we have the statement, volume is inversely proportional to the pressure at a constant temperature. Is it Charles' law? Is it Boyle's law? Is it Dalton's law? Is it Graham's law? Now, remember that according to Charles' law, it says that the volume of a given mass is what? Inversely proportional to the what? Pressure, given that the temperature remains constant. So this law, all right, is actually what? Boyle's law. All right, this is actually what? Boyle's law. So Boyle's law said that the volume of a given mass of the gas is inversely proportional to the pressure, provided that the temperature remains constant. Now the next question says, which of the following graphs represents the variation of pressure against volume at constant temperature? Now, they are asking which of these graphs actually represents what? Actually represents Boyle's law. All right. Now, don't forget that Boyle's law says that the volume of the given mass of the gas is inversely proportional to the pressure, meaning that you have an inverse relationship. All right, an inverse variation relationship, and the graph that best represents an inverse relationship between two or more quantities is this graph. All right. Apart from gas laws, all right, or Boyle's laws, just know that when you're talking about an inverse relationship between two or more quantities or between two or more variables, this is how the graph should look like. All right, so this is correct. Now the next question says, the only factor that affects the internal energy of an ideal gas is, it is actually the temperature. Even from the knowledge of thermodynamics, which is very important, it is noted that the only factor that really affects the internal energy of an ideal gas is the temperature. All right, now let's look at the next question. It says, what are the laws that form the general gas equation? What are the laws that form the general gas equation? Now, let's remind ourselves, what's the general gas equation? The general gas equation is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. All right? So, the gas laws that were combined to have, for us to have this general gas equation was Boyle's law, Charles' law, and Graham's law. So option B is our correct answer. All right. Now the next question says, number 5, the volume of a gas at 25 degrees Celsius is said to be doubled at. Now this question is very technical, but we're going to solve it because it's very simple. All right. Do not be afraid of this kind of questions. You just have to be technical while solving them. So it says the volume of a gas at 25 degrees Celsius is said to be doubled at. Now let's say the volume of the gas V1 is V. So they are trying to say V2 is going to be doubled at what temperature? All right. Now they said the volume of a gas at 25 degrees Celsius. That means T1 is equal to 25 degrees Celsius. All right. So let's say the volume of the gas initially at this temperature was V. All right. Now they're not saying at what temperature. That means T2 will the volume of the gas be doubled, and we are representing with V. So it will be 2 times V, all right, when it's V2, all right. Now, we know that we must add what? 273 to this to make it what? An absolute temperature, all right. We must add 273 to this. So what is it going to be? 273 plus 25. That's going to give us what? 892, all right. 892, that's 298, all right, Kelvin. All right, this is going to be our answer. All right, that's for this. Now, what do we do next? We know that seeing volume and temperature, we're going to apply Charles' law. And Charles' law states that what? The volume of a given mass of a gas is what? Directly proportional to the temperature. That the volume of a given mass of gas is directly proportional to the temperature, provided that the pressure remains constant, which we're not going to have V is equal to KT. And then making K the solver formula, you now have K is equal to V over T, which now gives us what? V1 over T1 is equal to V2 over T2. All right. Now, so we're going to apply this formula to solve this. So if we make, we're looking for T2, right? If we make T2 the solver formula from here, T2 is going to be equal to what? V2 T1 over V1. So T2 is going to be equal to, what is your V1? Your what's your V2? Your V2 is what? 2V multiplied by your T1 is giving us what? 298, all right, over, now your V1 is given to you as what? V. Now, of course, watch out, you're going to see that V takes away V here, so you're left with 2 times 298. So 2 times 298 is going to give us what? 596. All right. 2 times 298 is going to give us 596. Are we correct? Yes, we are correct. So it's going to give us what? 596 Kelvin. All right. 596 Kelvin. All right. So this is going to be the what? Temperature when this is doubled. All right. When the volume of a gas at this temperature is doubled, this is going to be what? The temperature. 596 Kelvin. Now the last one says, calculate the amount in moles of a gas which occupies 10.5 dm cube at 6 atm or 6 atmosphere and 30 degrees Celsius. Given that the gas constant is 0.082 atm per dm cube per Kelvin per mole. All right. So now let's solve that question. So now let's solve the question. It says that calculate the amount in moles. So we have the general gas equation, because seeing this question and seeing this constant, your mind should take you to the general gas equation, which is what? PV is equal to what? nRT. All right. So we're actually looking for the number of moles. And if you make number of moles solve your formula here, it is going to be simply equal to what? PV over RT. All right. So N is going to be equal to what? Now, our P is given to us as what? 6 atm. All right. Now, our V is given to us as what? 10.5 dm cube. 10.5 dm cube. Our temperature is given to us as what? 30 degrees Celsius, which we have to convert to the absolute scale, which will add 273. And this gives us 303 Kelvin. All right. And then we already have our gas constant given to us there. So N is simply going to be what? P, which is what? 6 times the volume is what? 10.5 over what? 0.082 multiplied by, what's the temperature? The temperature is 303. All right. So we have 303. Now this is going to give us an answer of 2.536 moles. All right. So the amount in moles of this gas is going to be 2.536 moles. So this is going to be our answer. All right. That's going to be our answer. Now, do not forget to like this video, share this video, and make sure you hit the subscribe button and also the notification bell, so that every time I upload videos like this, you get notified.